All right, guys. So this warm-up problem was the multiplication of two complex numbers. So let's see how this works out.
Can I do it?
Sure.
We know how to do this, sir.
See if we can find
Can I go from there?
The first thing to do, we do these, whenever we do a problem, it's,
I know how to do it.
so when we do this, we need to make sure we copy the problem down directly. So it's 4 minus I. Right. Which is the same thing as 4 plus negative I, yeah. So we can change this to 4 plus negative I. No? No? Alright, so then let's go ahead and let's do this real quickly. Negative 2 times 4, negative 8. Not today, just time is short. Negative 2 times negative I would be positive 2I. And 6I times 24 would be 24I, and then 6I times negative I would be minus 6I squared.
Mr. Close,
Yes.
I have a question.
What's that? Is it about this?
Yeah.
What's that?
Did that negative 8 come before negative 2?
This came from when we FOIL negative 2 times 4.
Yeah, that's what I'm asking.
And then negative 2 times negative I, 6I times 4, and then 6I times negative I.
But why is it squared right there?
What's that?
The,
Here?
yeah.
Because 6I times negative I would be negative 6I. Because you have I times I, which is I squared. You think of like negative 1 times 6 is negative 6. You can think of it like that. Let me just make sure one more time. Yeah. Yes.
It's
What the problems?
Anyway.
The original problem?
Where would it be?
No, it's not positive 2R. It's a negative.
Alright, so
8 plus
Negative R.
negative 2 times 4 is negative 8. Guys, let's quit talking, please.
Oh, never mind. Yes, it is.
Negative 2 times 4 is negative 8. Negative 2 times negative I is positive 2I. 6I times 4 is 24I. And 6I times negative I is negative 6I squared. So even though you think you may know how to do these, if you're not careful, you can get it wrong. And you got to be careful with math, right?
Yeah, I gotta see that. I flipped it.
So if we continue forward, I'd have negative 8 plus 26I minus 6 times negative 1. Because I squared is negative 1. So we have negative 8 plus 26i plus 6. And then negative 8 plus 6 is negative 2. So negative 2 plus 26i.
Oh wait, never mind. I was about to actually do
And now complex numbers are written in the form a plus bi. You usually don't see it as bi plus a, where a and b are real numbers.
I have a question now.
Yes?
Me?
Yes?
The negative 6 times negative 1.
Are you want to know about this?
Yeah.
I squared is negative 1, because remember I is the square root of negative 1.
Yeah.
The I being the square root of negative 1. So I squared is negative 1, so I'm just substituting negative 1 for I squared.
Okay. You have me confused.
Any questions about this? This should just feel like a review. This is something you'll definitely see on the test coming up. Shooting for next week. I'm not sure when. So now we've been solving problems like these radical problems, right? I want you to understand this, and this may be something you've already learned, where the square root of something can be expressed as to the 1/2 power. Are you?
Wait, how?
Okay, so the index of this guy is 2, even though it's not written, it's understood to be 2. And this whole thing raised to the, x minus 1 is like to the first power. Yeah.
Oh.
Okay. So I'm showing you this because I want to show you a problem that we started doing yesterday, and you were to finish the example. The example 7 is what it was.
Why did you put the half? Yeah, where's the half come from?
I'm just demonstrating that when we look at more problems that are quadratic in form, that you've already actually been doing equations that have fractional exponents, whether you realize it or not. You'll see, I'll tie it back. I'll tie it into when we start talking about the next problem.
If this the third power is 1/3.
Yeah, so if we have x to the, would you say? The third power? Well, x to the third power is just x to the third power. It's a nice whole. But it shouldn't be. X to the 1/3 power. Let's see if this makes sense. Would be all you do is you take these numbers and just rotate them like this. The 3 would become the index of the radical, and I really don't need to write 1, but. Good.
So 3 going, the bottom going outside.
Yeah, so let's do like one more example. X to the 2/3 power, that would be the cube root of x. And I can write the square here or write the square on the outside, it doesn't matter which.
And then you take that out. And then, so you would like square by 30, not square, but like, you put parentheses and then you put the 3 to get rid of the.
We'll probably see what you're talking about in a second here. Because we were to finish example 7, right? Yeah, okay. Was anyone able to finish this? No? Yeah. Emily, could you let Ebony go? You asked? Oh, I'm sorry, she did. Thank you. Alright, so if you missed this yesterday, what's going on here was that I'll quickly go for everyone, so just try to keep up if you missed yesterday. What we had in black, was what's written. Now this is quadratic in form because this exponent is twice the value of that exponent. So it's quadratic in form, okay? So what we do is, okay, let u be this guy, this x to the 1/3 power. Then u squared would be x to the 2/3. And then we can rewrite this, that's in black, we could write it in terms of u, and you notice, okay, great, we have a quadratic. Okay. So because this was quadratic in form, we can use u substitution to actually write it as exactly a quadratic. And then from here, this was just a review of, I guess, AC method. But you know, there's all kinds of methods that you might learn depending on the background of the way you were taught. I don't care what method you use, as long as you can get to this line here. I'm fine with whatever you use. Here, I happen to use AC method, where we say, okay, what factors of 10, 5 times 2, what factors of 10 add together to give me 11, and that was 10, 1. So I just broke up 11u as 10u plus u. Yes?
Were we supposed to plug it back in?
Plug what back in?
Like, you know how it took to the u, like, equals x and u.
Yeah, yeah.
Were we supposed to plug it in?
Yeah, so then we're getting, yeah, that would be the next thing you're doing, yeah.
I did it wrong.
But let's, so back to here, it's just a review of this. Again, I don't care, if you're comfortable factoring this, that's all that matters. I'm just showing you one particular method, I think it's called AC method, where we take the A, the 5, and the C, and the 2, multiply them together to get 10, and we say, okay, what factors of 10, when added together, gives me 11, and that's 10 and 1, right? 10 times 1 is 10, 10 plus 1 is 11, so I break up 11u as 10u plus u. Okay. And then it works out, the algebra works out kind of magically. It doesn't even matter how you place it. You could write u plus 10u. The order doesn't matter for the middle guy.
Could you go like 60 or 5?
No, because 6 times, because 6 times 5 is 30. So when we did the AC, the 5 times 2 is a 10, we needed factors of 10 that add to 11. And there's only going to be one possible combination that works like that, which happens to be 10 times 10 and 1, yes.
You put 5u squared.
Yep.
Is that because like u equals x
To the 1/3, yeah.
to the 1/3, and
Yep.
the 2 is like 2 over 3 or something?
Yeah, so if u equals x to 1/3,
Right.
if I square both sides, remember that when you raise something to an exponent, you just multiply the exponents. So 2 times 1/3 is 2/3, of course. So here, we're just factoring by grouping. Okay, so I group these, and then greatest common factor of these is 5u, greatest common factor of this is 1. And then now you notice, okay, they both have u plus 2 in common, so we factor that out, leaving us 5u plus 1. And again, we call this factor by grouping, yes.
The top, how do you get 10?
Okay, so I did AC method. What I did was I said, okay, AC method, so A times C would be equal to 5 times 2, which is equal to 10. I need factors of 10 that add to 11, this guy here. It's also called like ABC method is another name for the same thing. So factors of 10, if I list factor of 10, I have what? 1 and 10, and 2 and 5. Well, 1 plus 10 is 11, that's what I want. 2 and 5 is 7, so that's the one I want to use. So the 11u is just rewritten as 10u plus 1u.
Because that would equal 11.
Yeah, because then it allows you to do the factoring by grouping that works out. Thank you, Evan. All right, so then just that. So now we get to here, and again, I know you guys divide, slide. They have all kinds of different names or different methods for factoring. But
Do those cancel out?
so we get to what cancel out.
The u and the, like the plus u and the u plus 2 and u plus 2?
Well, they have this in each of these that are in red brackets. They each have u plus 2 in common. So I factor it out, leaving me 5u plus 1.
Yeah.
Mm-hmm. So now we are here. And then, so now we can say that u plus 2 equals 0 or 5u plus 1 equals 0. And now I could now go ahead and substitute right now if I wanted to x to the 1/3 for you, or do it later. Like I ended up actually solving for you for each one.
Why did you get that? Oh, here, you said.
How is that 1/5?
Negative 1/5. If I solve for you, I would subtract 1 on each side and then divide those sides by 5.
Oh, okay.
All right, so now I'm going to go ahead and erase this here so we have room. So now I'm going to go back to basically what I said. Okay, so now I'm going to substitute back in for you. So I'm going to say that x to the 1/3 is equal to negative 2. And I'm going to say that x to the 1/3 is equal to negative 1/5. I'm just substituting this value here into my u's here and here, making this statement up here. All right, so then now here's the last bit of this is that, okay, so I want to know what x is. I don't really care what x to the 1/3 is. So how do I get this to become x? Not multiplication.
Put
No.
it in square root. Put it equal.
You could rewrite it as a radical, but we don't even have to do that. This is actually this is why I want to bring this up. What will be the next step to solve this guy after we obviously isolate this radical? What did we do?
Square.
We squared both sides, yeah. And the reason that works out is because 1/2 times 2 is 1. So that's the same mentality here. What's that? Yeah, you cube it, exactly. So we're going to go ahead and we're going to cube both sides. We're going to raise each side to the 3rd power. I'm going to do that here. What's that?
Why again?
Because when you have an exponent raised to an exponent, you multiply. And 3 times 1/3 is 1. When you have an exponent raised to another exponent, you multiply the exponents.
3 times 1 and then 27.
This is x to the 1/3. And so I'm gonna raise it to the 3rd power because 3 times 1/3 is 1. So then now I just have x. X to the 1st, I'm just gonna write x.
Multiply the fraction.
And then negative 2, that's supposed to be, of course, be a 3, sorry. Negative 2 cubed is what? Negative 8, very good. And then now, same thing here. I'm going to raise this to the 3rd power.
Just have x.
X would equal, now be careful, don't just blurt something out, that's not correct. Actually think about negative 1/5 to the 3rd is negative 1/5 times negative 1/5 times negative 1/5. Multiplying fractions go straight across. What will we get? Yes. Thank you. Fantastic. Negative 1 over 125. So these are our, what we would call proposed solutions. Right? So just like when we dealt with an equation like this, we check our solutions, right? And they technically had fractional exponents. We just didn't see it because they were in radical form. So we should definitely check this. Okay? We should definitely check these. Okay? It's not as bad as you might think, because you actually already have done some of the math and repeats that you're going to do to check it. So let's check these. X equals negative 8, x equals negative 1/125. All right, so let's go with the first one, negative 8. Here we go. So we have 5 times negative 8 to the 2/3 power plus 11 times negative 8 to the 1/3 power plus 2 equals 0. Right? We're just checking to see if this is going to make a true statement. If it does, it is a solution. If it doesn't, it's considered an extraneous solution, or a false solution, if you will. This is where I think it makes more logical sense to the mind to write it in radical form. Because when we look at this, it's like, I don't know what that is, typically. So what I'll do is I will write this as the cube root of -8 squared. Because I think this is more intuitive, right? It's more logical to see, oh, I know the cube root of -8. That's -2. Because just before I did -2 cubed to get -8, so I already knew that was -2, and then square that to get 4. I think most students would prefer to do this, so that's what I'm going to do here. So plus 11 times, now this is the cube root of -8. I could technically write it to the first power, but it doesn't really affect anything. I don't have to write it. Okay, so 5 times. Now, what is the cube root of -8? -2. Why? Because it's the same thing. What multiplied by itself 3 times gives me -8? And if you go back, we actually already did this. And the work, we already had the situation come up where I said, okay, x to the 1/3 is -2. So when I cube both sides, oh, okay, x equals -8. So it's convenient that you actually kind of already done this. So let's keep going. So plus 11, the cube root of -8 is -2. Plus 2 equals 0. Let's see if we keep going. So -2 squared is 4. This is just a matter of just being careful. I think the toughest part about this, it's funky, is the fractional exponent. So that's why I just changed it to radical form. Because then I think you could look at this and say, oh yeah, this means the cube root. This means 1 multiplied by itself 3 times would be -8.
2.
-2.
Negative 2.
And this is maybe -22. Plus 2 equals 0. And just simplifying, so 20 plus -22 plus 2 equals 0.
20 plus 20.
I'm going to shrink this just a little bit. I want all on the same line.
Or 20 minus 20.
So 0 equals 0, so it checks off. So yes. It's made a true statement, so I know this works, right? All right, so let's go ahead and test the other one. Yes.
What's the difference between? Are you just doing it in a different way from yesterday? That's all you're doing.
What do you mean from the radical, from problems that look like, from problems that look like this? You mean?
No,
We said yesterday.
that one. Are you just showing a different way of doing it?
No. What I'm doing is I'm checking.
Oh, okay.
Putting it back into the equation and seeing if it works.
Always, check your solution. And that's what we're doing on the next page, basically. That's what we're doing here. I'm plugging in -8, see if it makes a true statement. Now I'm going to plug in -1/125th and see if it makes a true statement. We're probably not going to have any issues because the denominator of the exponents is odd, but it's just easier to tell you just to check your solutions if you have time.
Wow. So how?
So let's now check the other one. So now we're going to, so this one here, this was checking a -8. Now we're going to check -1/25th. So we have 5 times -1/125th to the 2/3 power plus 11 times -1/125th to the 1/3 power plus 2 equals 0. Yes, sir. You just want to check out the math? You want to reduce the mathematics? Oh, okay. Okay, I appreciate it. Thank you, sir. I appreciate it.
No problem.
So here, again, we can rewrite this. But you guys already know what the cube root of -1/120 because we did it when we did our work. Right? It was -1/5. But so basically we have the cube root of negative 1/125th squared plus 11 times the cube root of negative 1/125th to the first power plus 2, does that equal 0? I know it looks daunting, but you guys already did this in the on the work. When we did this, we found out, okay, the cube root of x is negative 1/5. Okay, x was negative 1/125th, so we know that this is just negative 1/5. So we have 5 times negative 1/5 squared plus 11 times negative 1/5 to the first power, which I don't really have to consider. Yes, question, yes.
What would happen if you say add the times the exponent and then square it?
Times the
Like
exponent.
you said 3 and 1, and you said multiply that and it's only 3 and then cube it. With 2 and 3 you can't do that, it's only 6.
I'm not sure. I'm not sure if I understand, but I can tell you this. All I'm doing is just simplifying this equation to see if it makes a true statement. That may be different than what you're thinking about when you're like solving for an unknown. When we were solving for x, yeah, I needed to cube both sides to get x. Here, I'm just.
I know how to do this.
All right. So then we have 5, and then negative 1/5 squared is what? Multiplying fractions is a lot easier than adding fractions. 1/25, good. Plus 11 times negative 1/5 plus 2 equals 0. Are you guys fine if I just say 0 equals 0, or do you want to see me do the fractions? I'm assuming you guys know how to add fractions and all that fun stuff. In order to add fractions, you have to have the same denominator. Yeah, no one likes to add fractions. If you know how to punch in the calculator, I'm fine with that as well. But your math on paper should be good enough to where, you know, if the calculator isn't cooperating very easily, you should be able to figure it out.
So what do you call it when there's an
What's that?
What do you call it when there's an solution?
What do there's no real, I don't know, there's a name for it. We would just say that these are the solutions. So they both check off. Yeah, both good. Any questions? Again, it may not be necessary to check when the denominator is odd, but I'm doing it just to be safe, because I don't want you guys to have to, memorize all these little rules. But you know, when you're fractional, just check it if you have time. Because not only are you checking to see if extraneous, but checking to see if you made a mistake, yes.
The test.
Sorry.
On the test.
Yes.
Will you mark off if we do not?
I will not mark off as long as the solutions that you say these are solutions. If they are the actual solution, you'll get full credit.
But if they're wrong, you don't know.
Yeah, I mean, if you give me false solutions, then obviously you won't get full credit. But if you show, first off, show your work.
Yeah.
You're going to get a lot of credit if all your work is good. And let's say you didn't have enough time, or let's say you didn't feel like checking. But your solutions are good because you know, okay, it's the 3 is in the denominator, it's odd. I don't have to check. I know I'm good at my math. I was very safe. You get them, you circle them, and you're good. You're good. I'm not requiring you to check. But however, if you were supposed to check because there may be extraneous, and there were, you're not going to get full credit if you say, oh, these are both solutions, when in fact one of them is definitely not one of the solutions.
Excuse me, sir.
Wait, I'm not finished.
Go ahead.
But because I understand, like I get how to do it, but I just like when you're playing it in, like it just confusing me.
Then let me say this. When you have the denominators are odd, it's not necessary to plug it in. Okay. Let's go with that. That's only that. I don't want you to get stuck on that, and then if one of them is even, and if both of them are even, and it doesn't work out. Okay, if you're careful with your math, and you have denominators that are odd, you don't have to check.
When's our quiz?
Probably sometime next week.
How many quizzes are we gonna have every?
I'm gonna try to give you more. I think it's, listen.